Hello friends, this is Anshuman again from TechnoKiddies.
Today we are going to build a crash prevention system for a vehicle. To build this system, we'll use the Arduino board. The ultrasonic sensor, a breadboard, a buzzer, and some jumper wires. So before we start, I'll show you. So this is the Arduino board. We are going to use the digital pins on the Arduino board. These are the digital pins. We'll not use the analog pins for this one. We'll use this pins there from where we'll get the ground and voltage, means the power will connect it to the breadboard. So this is the ultrasonic sensor. There are 4 pins in this sensor. So the first pin's name is VCC. VCC gets the power for this sensor. It will be like 5 volt from the Arduino board. Okay, it's positive. Then the second pin's name is trigger. One of these will send sound waves. The echo will receive the sound waves if it hits an obstacle, and the ground will connect it to the ground pin in the Arduino board. We'll use this buzzer to produce a warning sound if there's any obstacle near the vehicle. First, we'll connect the buzzer to the breadboard. I'll connect the positive pin in number 16. I'll use the positive as even number and negative as 13 is odd. So I'm using 16 for positive and 13 for negative. Now we'll get the power to the breadboard. We'll get the 5 volt to the positive point and the ground part to the negative point. Let's take one jumper wire. It's connected to 5 volt. No, this is female. What is this one? Orange. I'll take orange as we don't have many black and red wires. Let's connect. Now let's connect it to the positive point. I will use the gray one for the ground. Now it's connected it to the grid. Oh, I connected it to VIN. Now let's get the power for the buzzer. I'll use the white wire for the ground. Number 30. So now the ground is connected. Now we'll take the positive. We'll use the digital pin number 13 on the Arduino board. I did not connect I'm not getting the power supply direct from the positive point because I don't want the buzzer to keep screaming always. We'll control it from my program. Now let us connect the ultrasonic sensor. I'll use the white wire for the ground, which I'll connect it to negative point, and orange for positive. I'll use the gray one. Now the echo and trigger I'll connect it to the digital pins. I'll connect trigger with the gray cable to digital pin number 9. And echo, I'll use blue. Connected to number 6. Before I program my Arduino, I'll just place the whole system on my drum truck, and I'll put the ultrasonic sensor at the back. Now I'll connect the Arduino to my laptop. So this is the code where I'm going to type. Now I'll start with the program. I'll declare some constant which I for the pins which I connected on the Arduino. I will also declare some float variables. I'll arrange the code a little bit. I don't need these comments. Now I'm going to set the trigger pin as output. Echo pin as input. And buzzer pin as output. Now I will make the trigger pin as low. I'll explain you. Now this digital means that 0 and 1 means on or off, that if voltage is present or not. Now if I want to switch on a buzzer, I have to put voltage in it, right? If I want to switch off, I have to remove the voltage. Like that, low means it'll remove the voltage, and if I put high over here, then it'll put voltage. So now first I'm going to set trigger pin as low, since there will be no voltage in it. I'll give a delay over here for 100 100 milliseconds. Then I will make the trigger pin as high. Now I'm putting voltage inside this trigger pin. I gave low over here because to confirm that the trigger pin is not with voltage, means it will be 0. After it's confirmed that it's low, after 100 milliseconds I'll switch it on. I'll give a delay. After this delay, I'll make the trigger pin low. If I don't make it low, then the trigger pin will continuously generate sound waves. Now I'll give a line to print in the serial monitor. I'll use the print ln function for this. Say triggered. Now I'll compile and upload the code to my Arduino board. There are no errors. Okay, now let me open I'll open the serial monitor. The line are not. There are garbage values coming on the serial monitor. I'll close this one, minimize this. I give the wrong value for the baud rate, so I'll change it. Now let me see if it works. So I'll directly upload it. Let me open the serial monitor. So here's our serial monitor. So we got our output. Now what does this pulse-in function does here? The pulse-in function waits for a pin. I gave echo pin. It will wait for this pin to become high. When it becomes high, the pulse-in function will return a value in milliseconds, which we assigned in this duration variable. Now, when does this echo pin become high? Now, we define trigger pin as output and echo pin as input. When we write trigger pin as high, the sensor will generate ultrasonic waves. When that wave hits an obstacle, the waves will return back to the sensor. That time the echo pin will become high. What does this duration variable contain? The duration variable contains the time taken by the ultrasound from when it was generated by the sensor, hit an obstacle and returned back to the sensor, which is in milliseconds. Now I'll print the duration. I'll use the print function. And over here I'll use the println. And take the duration variable. Now I'll compile and upload my code. There are no errors. Let me open my serial monitor. So here we have the duration. Over here the values changing. Now I'll type the code to convert the duration into distance. For this we'll use a formula. I'll explain this formula after I am finished typing the code. This is the number which I found from the internet. This is the speed of sound, which is in centimeter per millisecond. I'm multiplying this number with the duration. The duration contains milliseconds, and I'm dividing it by 2. Why am I dividing it by 2? I'm dividing by 2 because as the sound waves went both two ways. That's why I'm dividing it by 2, so that I can get the one way only. Now I'll print the distance. Now I'll compile and upload my code. There are no errors. There's no errors. Now let me the serial monitor. So we got the distance too. Now
electric will be
now I'll check that if the distance is less than 10 centimeters, then I'll make the buzzer scream until it is greater than 10 centimeters. An if condition for this. I'll copy my buzzer pin and make it high. I'll give delay over here. I'll give 200 milliseconds, and then again I'll make it low. So it's like siren. Then I'll also print a line on the serial monitor. I'll print about to crash. About I'll just type in one delay over here too. Give 10. Now I will compile and upload my code. There are no errors. Let's see. Oh, I gave the wrong condition over here. I had to give less than, because if it'll check only if it's 10. Means it'll not be less than or greater. It'll just, if it's 10, then it'll print. The buzzer will start screaming. There are no errors. 5. Now we're here. We're about to crash. Okay, it's far. Let me move the vehicle now. We'll move the vehicle now. Now I'll disconnect the Arduino from my laptop and connect it to a power bank. I'll just make some adjustments over here. I want the wire to come in front. This can also be support. Okay, now it's fine. I will move the truck far away. Let us check and move my laptop. It's working. Good.
Thank you for watching this video, and I hope you enjoyed this video.